Hello everyone, I'm really crazy on Telegram. So I'm just showing you how actually the password of Crackme 3 file is uh, taken from the assembly code of the Crackme 3 binary executable file. Let me just show you that. Okay. Okay. So these are the files that you will get after cloning the repository link that's given on the last task of the bit manipulations project. So let's take a look on the readme.md file first. Let's readme.md. So they're expecting us to find the password for the Crackme3 program. So the usage should have to be .crackme3, then the password. After that, if we get succeed, then the congratulations message will be displayed. And if we just get failed, some other text will be displayed. So let's just write .crackme. Let's just try it with a random password, which is train. Okay, we know that LX train is not the exact password, so it will just display us KO message. So I'm assuming you guys have the basic knowledge on GDB debugger and assembly language, so I'm not going to explain each and every step on the cracking process of the Crackme 3 file. But you can just search on what commands I am actually using while cracking this Crackme 3 file, and what actually I am focusing on what assembly language mnemonic instructions I am focusing on. Let me just start the GDB debugging process. GDB Crackme 3. So set disassembly. Because program execution always starts from main, so I just started disassembling the main function. But before that, you can check what user-defined functions are included on the Crackme 3 file. So to do that, you can use info functions command. So it will tell you the function is used on this Crackme 3 binary executable file. So functions like puts, strl, printf, which are system-defined functions, and there are also user-defined functions like check password and main. So let's just map them, check password and main. So these are the two functions that the user created for this Crackme 3 binary executable file. So let's just take a look on the main function. It is assemble main. Okay, let's just breakpoint at starting. So okay, let me just step through it. And run. So you guys can map the assembly mnemonic instructions like push, move, sub, move, CMP, and something. But you need have to focus on these instructions, control flow instructions that are used to control the flow of the program. like CMP, JE, call, JMP, again call, CMP, JNE, and JMP call and return instructions. You can Google on how to use these instructions. I'm not going to explain what CMP function, what J function, what call function, what JMP function are used in assembly language programming. So let me just see the first CMP function, CMP instruction. The CMP instruction compares the takes two operands. The first one is the RBP 0x40, which is a base pointer, and the second one is a value. So it compares something stored on the RBP 0x14 base pointer with 2. So the program flow here is like this one. If something, let's just if we are assuming the variable as a, if a equal to, it's checking if a equal to, and if it equals to 2, that is jump if equal. This mnemonic is just JE jump if equal. So if they are equal, it will jump to the memory segment 6B1. So what is 6B1? 6B1 at this memory segment, it will move, and after that, it will just call the 6BF. At 6BF, it will call the check password user-defined function. So let's just step through it until we reach the 684, the instruction contained on the 684 memory segment. So 684. So we are at 684 memory segment. So at 684, it's comparing something with 2. So let's take a look what the comparison result will be. Okay. If it is equal, you can notice that if it is equal, it will jump to 6B1 memory segment, but our it's not equal, so it will not jump. It is not jumped to the specified memory segment. Instead, it's just executing the second instruction next to 684 memory segment. So you can take a look on 684, 688. Okay, then what we have to focus is that the call function 6A5. Let's take a look. It calls some fprintf function. The fprintf function just prints a text. You can just use the man page of fprintf to see what is the use of fprintf function is. So it's located at memory segment 6A5. So what text will be displayed? Let's take a look on it. ni A5, we reached it. And then it will print the usage information. So we have to run our program by providing password. If you can see it before, we just ran. Okay, let me just show you here. Okay, we ran our program without supplying any password. Password. So let's just run it again by supplying password so that it will pass this compare, and it will jump to 6B1 memory segment. So run, then password. Let's just put a random password. So yes, I want it. Breakpoint at 1, N9. What is the use of N9 and SI? You can just Google it on the internet. So you will get a lot more information about N9 and SI. So after 684, 688, 6B1, we are getting on 6B1 because the comparison is now get succeed. So this comparison is returns a true value. So jump if equal So it's jumped to 6B1 memory segment. Okay. Now you can just so this function is just trying to compare the argc value of, for example, we may have int main, int argc, and then car asterisk argv. Then this type of main function we may have. So it's on the first line, it's checking that if the arguments that are passed through to this function are true or not. If they are true, it will pass to some set of instruction, and if they are not true, it just displays this, the usage information, and finishes the program execution. So you can map the program stepping like this on some piece of paper. So let's just continue our debugging process. So let's just see Ni. So if it succeeds, it's 6B1 memory segment. What's 6B1? 6B1 is actually, okay, let's see, 6B1 is actually, okay, passing some value to PTR, and then we are not focusing on this instruction S. Let's just focus on the call instruction. So it calls the check password function. So after something is done, it will, if it succeeds, let me just write it here. If it succeeds, or if they are equal, if the arguments are equal, then it will call the check password function. So, so it will call the check password function at memory segment 5F6. Then after calling the check password function, we know that every function returns some value. So the returning value is usually stored at EAX register and the move dword PTR RBP 0x4 EAX. You can Google it on how what actually does RBP 0x4 EAX, RBP registers, RDX register, RAX registers on the internet, but it will just pass the returned value to this register and then compares if the returned value is 0x1. If it's 0x1, it will, if it's 0x1, if it's not 0x1 or if it's not 1, the entered value is not 1, it will jump to 6DE, memory segment 6DE, which is actually ending the program execution. So until this return. So, but what if it is succeed? Let's just take a look on it. So if it is succeed, or if the function, if the check password function returns 1 to the calling function, that is the main, to the main function, so it will just process these things and call some puts. We know that there is a of puts function which prints a text as printf. So after that it clears EX register, and then after printing some text, it will move to the 6ED memory segment, which is just returning or leaving the program execution. So let's just set RBP, the content of RBP 0x4 register to 1 and see what message we are actually getting. We are expecting that if the comparison result is equal to 1, or if the check password returns 1, it should have to print congratulations message to us. So let's just do that. So we are at memory segment 6B9. We need have to move until we reach the memory segment 0x6BF. No, 6. The comparison process is at 6C7. So let's do that. Okay. Again, N9, 6C7, we reached. So we are on C7, so let's set the content of RBP0x4 register to 1 so that the comparison result will become 1 equals to 1. It is true, so it will print the congratulations message to us. So let's just x/xw. And you can Google on how to use the x/xw, x/xt, x/b, x/xs, and so on instructions on GDB. So x/xw with the RBP 0x4. So, oh my gosh. Let me just add the $sign because it is a register. So this is the memory segment value. So this memory segment contains currently 0. So it's assuming that we have entered some wrong password. We know that we entered random password. So the check password function checks our password, and he knows that, it knows that the password is incorrect, so it returned 0 instead of 1. So the comparison will be failed, and some KO message will be displayed. So to avoid this thing, we can just put set int the value of this memory segment to 1, so that the comparison result will become true, equals to 1, or we just say 0x1. Now let's just take a look on xw. RBP 0x4. Now it's set to 1. So the comparison result will become true because 1 equals to 1, so it's true. So we are expecting the congratulations message to be displayed to us. So let's take a look by executing single step 6CB6D2. So we are getting congratulations message at memory segment 6D2. So let's take a look on it. Okay, memory segment 6D2. So it just calls some puts function to print something. After that, some GMP and leaving the program execution. It's simple. You can walk through it by mapping the mnemonic, the assembly mnemonic instructions on paper. So let me just disassemble again it and start. What actually the check password function contains, because the password is stored, the actual password is stored at the check password function. So let me just do that. Disassemble again main break asterisk main. So let's just run it with some random password. Okay, yes, enter N9 for single stepping through the instructions. And if you are doing single stepping through functions, you can use SI. You can just Google what's the difference of SI and N9 on GDB. So you can get a lot of information about those things. So let me just 999 until I reach the call function, which is a memory segment 6BF. So 6BF. So this I want to just step through the function other than step through the instructions. If I used NI, it will just execute after 6BF, it will execute 6C4. But I want to get into the check password function, so I can use SI. So now you can see that it's just converted into check password because this memory segment is available in check password function. I mean, the check password function is located at this memory segment. So let's just disassemble the check password function and see what it actually contains. So you can use disassemble check password. So you can see that these are the assembly instructions contained at the check password function. You can ignore everything except call CMP, JE, JMP, or something. And you can map the instructions, these control instructions on paper, and see and keep track the actual flow of the instructions to get the password. So let me just show you something here. The first thing that will, okay, let me just walk through it with an instruction. So we are at memory segment 5F7. Let's just take a look on it. 5F7. So let's just do something. Record ptrdi. Okay. Here we do have a call function. A call function calls the strl len function, which is actually we know the use of str len function. It just counts the length of the string. So, and after calling this function, it's just comparing the result from strl function to 4, to the value of 4. If it is 4, it will just proceed. If it is 4, it will just jump to memory segment 61B, and the step is same as what we have seen on the assembly instructions of main. So if it's not equal, it will just do these things. So we are expecting some string length to be 4. You can see here that. So let's just see what actually it can do. Ni. Okay, we are at memory segment 602. Okay. We are at 602 until 60E. We can do. Okay, we are at 60E. So if the comparison result is 4, it will jump to this memory segment. But if it is not 4, it will just execute 614. So let's just take a look on it. 614. So the comparison result failed here. So you can think that initially, while executing this program, we just passed like this run password. The length of this string is actually 1, 2, 3, 4, 5, 6, 7, 8, but it is expecting 4. So we have get some int that the password of for the length of the password to get the actual the length of the password for the actual password is 4. So we can run our program again with only 4 arguments to pass that CMP instruction. Or let's just run with hell because it's 4. So yes, n9 until we reach the function call is actually okay, on the main. Okay, the check password function is located at 6pf. So until 6pf we can do n9. After that si, we are in the check password, then disassemble check password. So Okay, we are in the check password. So let's just see until 6 memory segment 6 OE. So we can use N9 until we reach 6 OE. So we are at 6 OE. Now the length of the password that we have entered is 4, so it should have to pass it and execute the instruction located at, or the instruction stored at memory segment 61B. So memory segment 61B, okay. It should have to execute this instruction. So let's just take a look. And 9612 and then 61B. We have got succeed because the length of the password is 4 characters only. So in this way, you can map the entire instruction on paper and keep track using NI and SI commands of GDP to step through it. Let me show you something here. 61B. So after that, it is storing some constant value to RBP 0x4. And if you keep track the entire program execution process, you will be noticed that it will compare byte by byte the bytes included at RBP 0x4 register. So let's just see the content of RBP 0x4 register because it contains a constant string which may be our password. So we can guess that our password is 0x46C6F48. It may be because it's comparing byte by byte. You can keep track until you reach this CMP instruction. So let's just take a look the content of RBP 0x4 register at 61B. So we are at 61B. So here we can make XW. Okay, RBP 0x4. Okay, so X by XS at this memory segment. What is the data contained at this memory segment? We are expecting string data, so let's just take a look. Oh, it's in bit string. Okay, X by XS and RBP 0x4. Oh no, RBP 0x4. Okay, we are getting an empty string. Okay, in which memory segment we are in at 61B. Let's just step through one step, 622. Let's see, 622, it moves, and 626. Okay, and again 626. Let's just take a look. Now on the RBP register, RBP 0x4. Oh my god. We can see that it contains some text. That is HOL and some special character. After that, debugging termination characters. String debugging termination characters. That's 377, 177. You can Google on. You can search on. You can Google on the internet what actually does this garbage elements mean. But we need to have to focus on these 4 variables because these 4 variables are our actual password stored at RBP 0x4 register. But we don't know this. We know that the first 3 characters are HOL, and then the last character is like just 0004P. I don't know what this value does mean, but we can just know what the last character is by just converting this 0x46 6F48 hexadecimal value to string. So let me just put it here. Now let's just open the ASCII value of characters. So man ASCII. So the first character is 48. So what is the equivalent for 48? And before this, let me tell you something. Where we are considering 2 and oh my god, 2 and here also 2 and here also 0 for 2. Because let me just show you that on the program. It is storing a word, not a byte. It's not, if the mnemonic instruction is d byte ptr instead of like this d byte ptr, d byte ptr instead of the word ptr, we are going to consider only one element. I mean only one hex value. But for this case, it is the word ptr. We know that word means it's just 16 bits, which is 2 bytes, and byte means it's just 8 bits. So it is storing word by word. Word by word means 2 bytes. So we are considering 2 bytes, and we will try to analyze what is the ASCII value of 48 in hexadecimal and 6F in hexadecimal, 6C in hexadecimal, and 04 in hexadecimal. So let's just take a look on that. Okay. The first one is 48. So 48, the ASCII value, the hex ASCII value of 48 is actually H, capital H. So we will write capital H and then the hex value of 6F. Okay. 6F, hex value. Hex value of 6F is actually O. So O. And then the third one is 6C. 6C is L. So, and the last one is 04. So hex value of 04 is EOT. So the last character will be EOT. So let me just close this. This is a constant stored at RBP0x4 base pointer register, and the program compares byte by byte at the on the contents of RBP 0x6 register with the password that we have entered it before. So we know that the constant password is 0x46 C6F48, and we mapped it to string as whole and then EOT some command line, some control command, it's some control command. So what does it mean by EOT? You can just EOT stands for end of transmission, end of text, and there are so many abbreviations for EOT, but you can search it on Google, like on Google for what is the You can say what is the control command EOT stands for. And it will definitely tell you that it will stand for control D. So D. So EOT is replaced by this command control. So EOT, you can Google, you can find it on Google, so that it will tell you the EOT replaces the command control of control D. So the last character is control D. So you can replace it here, control D. So we get the actual password of the Crackme 3 file, that is whole, then after whole and control D. So let's just try this password. Okay. ls./crackme3. After that, h small o l, then control D. Yes, we get the congratulations, Michelle. So in this way, you guys can get the actual password of Crackme3 binary executable file. I hope some I hope you guys get some basic understandings on how we have to trace the real program execution flow using CMP, JMP, JE, JNE, and return commands. So this is my first time. I don't have any experience before on explaining things like this. It may be bad, but I hope you guys get some basics of cracking such binary executable files using GDB. So that's all about the Crackme 3 walkthrough, and hope you enjoyed it.